Hello and welcome to IP Study Video Lectures. And today we are going to discuss Chapter 11 from Grade 7 Social Science, and the name of the chapter is Our Dynamic Planet. In this chapter, we are going to cover important topics like endogenic and exogenic forces, formation of landforms by endogenic forces, earthquake, volcanoes, and lastly, formation of landforms by exogenic forces. So now, let us have a brief introduction about this chapter. So we all know that Earth is a dynamic planet, and by dynamic we means that there is a constant change going on the surface of the Earth as well as below the surface of the Earth. Okay, and the geological history of the Earth also show us the formation of different landforms like mountain, plateaus, plains and others. And this proves that Earth is going through constant and continuous change and evolution. Okay, and this evolution of the Earth is mainly because of two important forces. First one is endogenic and second one is exogenic forces. So now let us come to the first topic of the chapter, that is endogenic and exogenic forces. So the movement of the Earth is broadly divided into two categories based on the force behind it. Okay, first one is endogenic forces, second one is exogenic forces. So what do we mean by endogenic forces? So those forces that origin within the Earth crust. Okay, these are the forces that origin from within the Earth crust, and it creates two type of movement. First one, slow Earth movement. Second one is sudden Earth movement. So slow Earth movement, as the name itself states, that it is a very slow movement and it takes place for a long period of time. Okay, over a long period of time, such as continental building process or formation of mountains or different landforms. So these forces lead to this slow Earth movement, causing formation of continents, and it is a very long process. On the other hand, sudden Earth movement, just like volcanic eruptions, earthquake, landslides. So these are sudden Earth movement. Okay, it doesn't take much time. It happens all of a sudden. Earthquake, all of a sudden. Volcanic eruption, all of a sudden. Okay. So now, second force is exogenic forces. Endogenic, we already discussed those forces that arise from within the Earth crust or Earth's surface. Exogenic, on the other hand, are the forces that act on the surface of the Earth and cause change in the landforms and landscape on the surface of the Earth. Okay, different agents like wind, water, ice, they act and change the different landscape on the Earth surface. Okay, so these are the exogenic forces. Now let us come to the second topic, that is the formation of landforms by endogenic forces. As we already discussed, slow Earth movement, it takes place or it occurs for a long period of time or over a long period of time. Okay, and these movements are mostly related to tectonic activities or Earth crustal movement. Okay, tectonic activities we'll discuss. It is related to plate tectonic theory. Okay, and Earth crustal movement, the movement of crust, the layer of our Earth, the interior part of the Earth, the crust. Okay, so now what is the theory of plate tectonic? So the plate tectonic theory states that the Earth lithosphere is composed of several minor and major plates, and these plates are called lithospheric or tectonic plates. Okay, suppose this is our Earth, so it is form of different plates like this. Okay, different plates, and these plates, what they are doing, they are floating on the mantle below, molten mantle. Suppose these are different plates and this is mantle, so they are on a floating state, they float, and it causes movement on these plates. And why do they float and why there is movement? Because of the heat from below, the interior heat. So because of the interior heat, it forces the plates to move okay, and it collides with each other, it passes through each other. So there are different movements on these plates. If you can see here in the diagram, here, see these plates, they are floating on this, and the heat from below or interior, it causes them to move, or there is a movement because of this disturbance. Now, when these plates move and it sometimes collide, or it sometimes goes away from each other, it causes tension, compression, leading to the formation of different landforms and change in the landscape on the surface of the earth. So plate tectonic theory states that the earth is composed of many plates, major and minor plates, and they float on the molten mantle, okay, and because of the interior heat, there is a movement and disturbance, and when this plate move, it collide, it moves away from each other, leading to tension or compressional force, and eventually landforms are formed on the surface of the earth. So plate tectonic theory postulates this. Now let us see different types of plate boundaries. First one is divergent plate boundaries, second one is convergent plate boundaries, and lastly transform plate boundaries. If you can see here in the diagram, divergent plate boundaries. In this plate boundary, suppose these are two plates. These two plates, it moves away from each other. Okay, as we can see here in the diagram, this one is moving here and this one is moving here. Okay, convergent plate boundaries, here two plates, they move towards each other and they collide. Okay, they move towards each other and they collide. And lastly, the transform plate boundary, where the two plate boundaries, they do not move away or move toward, but they simply slide, okay, like this. This plate is coming this side and this plate is going this side. So they simply slide. Okay, there is no collision or there is no divergence. So now, why are these plate boundaries important? It is important to understand that when a particular plate or two plates, it moves away from each other, in case of divergent plate boundaries, it results into formation of continents and ocean basins, because when these two plates, it moves away from below, the molten magma, it erupts and comes on the surface of the earth and leads to the change in the landscape. Before it was like this, and suppose if it move away, now the magma comes and here landform is created. Okay, in case of convergent plate boundaries, here two plate boundaries, they move toward each other, they collide, and as a result, mountains and other landforms are produced. Okay, so now let us discuss the formation of mountains. So the formation of mountain is attributed to two types of plate movement. First one is convergent and second one is divergent. Firstly, folding. So folding occurs when two lithospheric plates, they move toward each other, they collide and creates compressional force. Okay, so suppose this is one plate, this is one plate, they move toward each other, they collide here. As a result, compressional fold is created, which result into formation of wrinkling or fold on the surface of the earth. Okay, this and this, different mountains are built. Secondly, faulting. When there is a fault or a crack or a fracture on the earth crust or the plate, so what happens is one portion, it might get uplifted and the other portion might get pushed below or down. Okay, suppose these are two plates and there is a crack here. So what happens, this portion might get uplifted or this portion might fall down below. So as a result, there is a change in the landscape and this is called faulting. So if you look at the diagram of the fold mountain here, we can see two important features here. First one is anticline, second one is syncline. So what are anticlines and synclines? So anticlines are the upfolded part of a ridge or a mountain. This portion is anticline, and syncline, this portion is the downfold, this portion, exactly the opposite. Okay, this top portion is anticline, and when there is this portion is syncline. Okay, now let us see some examples of old fold mountain. So old fold mountain examples include Appalachian in the USA, Urals in the Eurasia, and in India it's the Aravalli range. They were formed millions of years ago. Okay, and their features are they have rounded peaks. Okay, they have a gradual slope, and they are smaller, or their height is lower than the younger fold mountain. On the other hand, when we talk about the new fold mountain, its example includes our Himalayas, the Rockies, Alps, and the Andes. Okay, and they are still subjected to convergent plate movement. As a result, it is said that their height or altitude is still increasing. Okay, their features, they have a very pointed peaks, they have a steep slope and valley, and they are taller than the old fold mountains. Now comes the block mountain and rift valley. So block mountain and rift valley are formed because of the faulting. Okay, if you can see here in the diagram here, as I already discussed, suppose there was a fault here or a fracture here. As a result, this particular block, it got uplifted while this portion got down below. Okay, or was pushed down. So as a result, this portion is called the block mountain or horst, and this portion is called the rift valley. Examples include our Vindhyas and Satpura range. Okay, Vosges in the northern France, and Black Forest mountain of Germany. So these are the example of some block mountain. Now let us discuss the topic of earthquake. So what are earthquakes? So earthquake are sudden movement or vibration that we feel because of endogenic forces. And why does this happen? Because of the sudden release of the energy that was building up deep below the earth's surface. Okay, earthquake also occur if there is a movement in the lithospheric plates, or volcanic eruption, or if there is a faulting in the crust of the earth. Okay, and earthquake causes large and massive destruction on the surface of the earth. It causes the loss of property, lives, and many more. So if you can see here the image, the diagram of the earthquake, right? So what is this? This is the focus. So it is the point of origin of the earthquake. Okay, from here, because of sudden disturbance, earthquake originates here. This is focus, and vertically above the focus on the surface of the earth is the epicenter, and it is the most damaged region of the earthquake because it is vertically above the focus. Okay, and these are seismic waves. So once the earthquake or vibration originates, it spreads in every direction in the form of waves. So these are seismic waves. So now the study of earthquake are called seismology. So the study of earthquake waves are called seismology, and the scientists who study these waves are called seismologists. Okay, the earthquake is measured with the help of instrument called seismograph, and the magnitude of the earthquake is measured with the help of Richter scale, and it ranges from 0 to 9. And the higher the scale in Richter scale, the greater the intensity of the earthquake or the magnitude of earthquake. Okay, so higher the magnitude, greater the damage. So this is a case study of earthquake now. So in this case study, it has discussed the damage and the destruction of earthquakes. One, it has discussed about 2005 when the earthquake hit Muzaffarabad and its surrounding region, all the casualty and the damage it done. And second one is Republic Day earthquake in 2001, and the epicenter was Bhuj. So it has discussed the damages, what casualty it did, and everything. Now let us discuss volcanoes. So what are volcanoes? So volcanoes refers to the opening in the crust of the earth which allows hot magma, gases, volcanic ash, molten rocks and other materials to escape from below the earth's surface. And on the basis of the frequency of eruption, volcanoes can be classified into three types: active volcanoes, dormant volcanoes and extinct volcanoes. Active, dormant and extinct volcanoes. So when we talk about the active volcanoes, these volcanoes have erupted in the past or have erupted recently and is also expected to erupt in the coming future. Okay. For example, Mount Kilauea in Hawaii, Mount Etna in Sicily, Mount Vesuvius in Italy, Barren Island of India, it is the only volcano of India, and Mount Eyjafjallajökull in Iceland. So these are the example of active volcanoes. Dormant or sleeping volcanoes. So these volcanoes, they have erupted in the historical times and it is expected that there is a possibility of eruption in the future. For example, Mount Mauna Kea in Hawaii and Mount Kilimanjaro in Tanzania. And lastly, extinct volcanoes. They have not erupted for a long period of time, okay, and they are not expected to erupt in coming future. For example, Hauskaren in Peru and Mount Buninyong in Australia. So these are the example of extinct volcanoes. So now let us discuss the topic of formation of landforms by exogenic forces. So when we talk about exogenic forces, there are three important processes that plays important role and causes the change in the landscape on the surface of the earth. And these are weathering, erosion and deposition. What is weathering? So it is a gradual process in which the rocks break down and decays due to the atmospheric conditions such as change in temperature, frost or chemical change. And this is an in situ process. And what does in situ means? It means that the weathered rock particles are not transported from one place to another. So okay, it remains there only. Second comes erosion. Erosion refers to the wearing of the land surface and transportation of eroded material by different agents such as wind, rain, ice and others. Okay, and this movement of this material from one place to another results into change in landscape of the region. Third one is deposition. So in this process, the eroded material by different agents are dropped or deposited in another place. In this way, the landscape gets changed. Okay. Now let us see the work of river. So as we all know, river is a natural channel of water and it erodes the landscape over which it flows. Okay, and during its journey from the source to its mouth, rivers, it performs three types of processes: erosion, transportation and deposition. If you look at the diagram of a course of a river, we can see here it is a source. Source means the origin of the river, and here is the mouth. Mouth means the point where river empties into another body of water such as lakes or oceans. Okay, and when we talk about the course of the river is divided into three: upper, middle and lower. Okay, and river, it creates different type of landforms in its different course. In upper course, it creates different type of landforms. In middle course, it creates different type of landforms, and in its lower course, it creates different type of landforms. Now let us discuss the work of river in its upper course. So river origins in the mountains and hills and it flows, and in this portion or course, the main action of river is erosion. And first landform it produces V-shaped valley. Okay. So what is V-shaped valley? So in V-shaped valley, we can see the alphabet V. Because of the high velocity of the river water, it erodes the riverbed here and also the bank side. So in course of time, a V-shaped valley is created because of the action of river. Okay, so this is V-shaped valley. As we can say, it resembles the alphabet V. Now comes the I-shaped valley or gorge. So when the rivers, it erodes the bed at a higher rate than its bank, a very deep and steep valley is formed, and this is called gorge or I-shaped valley. So this is an example of I-shaped valley. Here we can see the letter I here. So the sides or the slopes, it is very steep in this type of valley. Okay, river, it erodes the bed faster than the bank sides. So vertical erosion is greater than the sideward erosion, leading to the formation of I-shaped valley or gorge. Now comes waterfall. So when the water of the river falls from a certain height, waterfalls are created. And waterfalls are created when there is a band of hard rocks and soft rocks. Okay, so river, it erodes the softer rocks at a greater speed. As a result, there is a change in the landscape. Okay, as we can see here, so this is a harder rock. Suppose the original landscape was like this, and this was harder rock and this was softer rocks. But in course of time, the river, it eroded the softer rocks, and as a result, there is a fall of water here, leading to the formation of waterfall. So now let us discuss rapids. So what are rapids? So when there are alternating bands of hard rocks and soft rocks, what happens? The river, it erodes the softer rocks at a greater speed than the harder rock. As a result, steps like landform is created. So thus this leads to the tumbling of river. So this is called rapid, and it is mostly found in the upper course of the river. So now let us discuss the middle course of the river. So once the river leaves the mountains and enters the plain, its velocity decreases. And here the main work of the river is erosion as well as transportation. So first landform, it creates its meanders. Okay, meanders we can see here in the picture. So this loop, since the water, its velocity decreases, the river, it starts to move in a curve way or in a loop. So this is a meander. See, this is the best example of meander. We can see the loop here. See, all this loop. So this is called meander. Okay. So now let us discuss oxbow lake. So now in the middle course of the river, it flows in a curve or in a loop, right? Now what happens? It erodes the outer banks. Okay, so this is the outer bank. So it erodes this while it deposits materials in its inner bank. Okay, so outer bank, this is inner bank. Outer bank, this is inner bank. As a result, this loop, it comes closer to one another, and in course of time, these two loops, it joins, and now the new course of river will be like this. And the leftover loop or curve becomes a lake, and this is called oxbow lake. We can check in the image here. See, oxbow lake. So if you see here, the original path of the river was like this. Okay, like this. The original path was like this. But because of this winding course, this portion is left out. The river met here and started flowing like this. So this portion is the oxbow lake, and this is the meanders. Okay. So now let us discuss floodplain. So during the rainy season, the water from the river overflows into the surrounding area and flood the area. Also, it deposits the fine sediment that it carries, and in the mean course of time, this deposited sediments, it forms a fertile plain called floodplain. Another landform the river creates in the middle course is natural levees or levee. So these are the raised ridge of sediment and debris on the bank of the river. Okay, so when river floods the area, it deposits sediments on its bank, and in mean course of time, the river bank, because of the deposition of the sediment, it get raised. Okay, so this is the natural levee. We can see here in the picture. See this. So this portion is the raised bank of the river, this portion, and this is called the natural levee, this portion also. Okay, the raised bank because of the deposition of sediments. Now comes the lower course of the river. So during the lower course of the river, the speed of the river is very sluggish, and the main action that the river does here is deposition. So the first landform, it creates its alluvial fan. So what is alluvial fan? So once the river enters the plain from a mountainous or a slopy region, it deposits the sediments it carries. Okay, and in mean course of time, a fan-shaped landform is created in this area. This is called alluvial fan. See here, right? Now let us discuss delta. So when the river reaches the mouth, or at the mouth of the river, the main channel of the river, it divides into numerous channels called distributaries, and all these distributaries, they deposit the sediments that they have brought. Okay, and in the mean course of time, this deposition of sediments leads to the creation of a triangular landform called delta. See here, the triangular landform. Okay, and now lastly the estuary. So it is a inlet, it is a narrow inlet, and it is a zone in which the river water and the water from the sea, the fresh river water and the salty ocean water mix and form a brackish water. So this is estuary. If you have to see the images of estuary, so this is an estuary. Okay, as we can see here, it is partially enclosed, and this is a narrow inlet here. Here the salty water from the ocean and the fresh water mix here and form a brackish water zone. Now let us see work of moving ice. In winter times, there is heavy snowfall in the mountainous region, and snowfall accumulates on the valley side, and this snowfall in mean course of time, it slowly moves down due to the action of gravity, and this is known as glacier or river of ice. Okay, and glacier creates different type of landforms. First one is U-shape valley. As glacier move downhill, it slowly moves, it erodes the surrounding region, right? It erodes the bed and the sides, and in mean course of time, it leads to the formation of a valley that resembles the U shape of English alphabet. So this is called U-shape valley. So this is a photo of U-shape valley. As you can see, it is wider than the V-shaped valley, and it resembles the alphabet U. Second is moraines. as glacier moves forward, it collects different materials, okay, such as rocks, sands and silt. And when the glacier melt, all these materials that the glacier has transported is deposited on the edge or along its path, and this material is called glacial moraines. Third one is cori. Okay, so cori are landforms created on the side of the mountain. They are depression or hollow-like shape due to the action of glacier. So the picture of cori is this. As we can see here, this portion and this portion are cori. These are hollow depression on the side of the mountain. And now lastly, tarn. So when these cori are filled with water, when the ice melts and it fills the cori, lakes are formed here, and these lakes are called tarn. So this is tarn, okay. Now lastly, icebergs. So what are icebergs? Sometimes the glacier, it does not melt and it reaches the ocean and it breaks up and small fragments of glacier float on the ocean. These are called icebergs. So now let us discuss work of wind. Wind is a very important agent in the arid or desert region. Okay, it erodes, it transports and it deposits materials in the arid region. And since there are less vegetation cover in the desert, wind blows freely and thus it helps to create different type of landforms like mushroom rock. So in the desert region, these rocks can be formed, and these rocks are formed when the lower portion of the rock is eroded much more than the upper portion. As a result, a mushroom shaped rock is formed. If you can see here, this. It has a wider top and narrow base. Sand dunes. It is a depositional landform created by wind. So wind transports materials like sand and small rocks, and it deposits these materials in some other region, and thus forms landforms like hill-like structure, and these hill-like structures are called sand dunes. Third one is loess. So loess are fine, lightweight sand grains which are carried by the wind, and the wind, it carries this sand and it deposits in some other places, and these deposits are called loess, and these deposits are very fertile. Now comes the work of sea waves. So sea waves are very important erosional and depositional agent in the coastal region. Okay, it erodes and it also deposits material leading to formation of different landforms. First one is sea caves. So sea caves are hollow-like structure or landform created due to the action of sea waves on the rocks. Okay, so when the sea waves, it strikes the rock again and again, it erodes the rock slowly, and eventually a hollow cave is developed, and this cave is called sea cave. See, this is the example, this is the photo of sea cave. Okay, and this is formed due to the action of sea waves on the rock. Now comes the sea arcs. So when the sea cave, because of the action of river, the hollow, it widens, and as a result, it completely erodes the cave and we find an arc. Okay, so this becomes the sea arc. So before, this was a cave, okay, this was a cave here, but due to the continuous action of continuous action of sea waves, this cave totally got eroded and arc-like structure is formed. So this is the photo of sea arc. Now comes stacks. Okay, so when the sea arcs, it is further eroded, and what happens? The roof of the arc collapse and only single structure remains there, and this is called the sea stack. This. Okay, so before this used to be a cave. Okay, and what happens? This rock was eroded, it became cave, and once the cave was eroded, it became sea arc, and finally when the roof also collapsed, only a stack remained here. So this is sea stack. Sea cliffs. So it is a steep and vertical rocky cliff that rises directly from the water of the sea. So this is sea cliff. See the vertical. Okay. Now the last landform created by sea waves are beaches. So these are common deposition landform created by sea waves, and it is gently sloping shoreline filled with materials like sand, rocks and pebbles. Right, we can see here gently sloping here. Right, it is filled with sand, pebbles and smaller rocks, and this is a depositional landforms. Before this landforms, we studied about the erosional landform like sea caves, sea arcs, stacks. These are all erosional landforms created by sea waves. Beaches are depositional landforms. Now we have come to the end of the chapter. So now let us revise few important points that we have discussed in the lecture. Firstly, the plate tectonic theory states that the Earth lithosphere is composed of several minor and major plates, and these plates are floating on the molten mantle. Okay. Second one is Earth is a dynamic planet, and two important forces that act on Earth is endogenic and exogenic. And to measure the magnitude of the earthquake, a scale called Richter scale is used. Okay. Volcanoes, it can be classified on the basis of its frequency of eruption, and there are three types of volcanoes: active, dormant and extinct. Weathering, erosion and deposition, these are the three exogenic forces, and they play a very important role which help to create different landforms. The path followed by the river from its origin, or we can say source, to its end or mouth is called the course of the river. Gorge, V-shaped valley, waterfalls are some of the erosional features of river. Certain depositional features are floodplain, levee, delta. Mushroom rocks are product of wind erosion, whereas sand dunes and loess are result of wind deposition. Caves, cliffs, arcs and stacks are found by the erosion action of the sea waves. So with this, I end our lecture today. I hope our lecture was able to clarify your doubts regarding this chapter, and we'll again meet in our next lecture. Thank you.